In the last class, I told you to go through the various file systems, like what is the file system of Microsoft, then your Apple, and then the Linux. Have you gone through it? Yes, anybody who has gone through the file systems? What is file system? Can anybody tell me? Because we are going to study about the HDFS, that is Hadoop distributed file system. So before going for the Hadoop distributed file system, we have to understand what is file system, then what is
Ma'am,
distributed file system. Yeah.
ma'am, how data is stored in computer and how operating system controls the data, how data is stored in the system and
Okay.
retrieved.
Perfect. Then can anybody tell me what is the size? Am I not audible?
And you are audible.
Okay. Can you tell me what is the size, maximum size of the file we can have on the Windows operating system? Anybody? Okay. Before that, can you tell me the file system name of some file systems on the Windows or Apple? The names of file systems on the Windows. You can check the name of the file system on your machine which you are using. On your laptop, check what is the file system.
Ma'am, NTFS,
NTFS. And before that, what was the oldest file system that we used to have on the Windows? FAT file system. Remember? So what do these file systems mean? Anybody? Okay. Is it visible? Slides are visible?
yes ma'am.
Okay. So, and today we are going to discuss about the Hadoop, that is HDFS in further details. So, what does this stand for? See, when we are talking about HDFS, this stands for Hadoop Distributed File System. So, let us start from the file system first. So, we say that in all the operating systems, we can store all the data in the form of files and folders. And how these files and folders, the hierarchy is being created, and the way they are stored in the persistent storage is determined by the different types of file systems, and they are according to the various kinds of operating systems they have been provided. So in the Windows, we can say we had the FAT32 file system, where the maximum size of the file could be 4 GB and the total volume limit was 32 GB for that. And then came the new file system, that was NTFS, whose maximum file size which it supports is 16 exabytes. So you can understand the maximum size of the file that is supported by the NTFS. Similarly, the HFS and HFS Plus, they are basically the file systems which are there in the Apple, and they have the, you can say HFS is an extension, the higher version of that. It supports the 8 exabytes file limit. And then we have the Linux, where we have ext3, 4, then XFS, which supports the 8 exabytes. So 2 terabytes to 16 terabytes to 8 exabytes, that is the file size limit. So we have all these file systems which can store huge amount of data. So why we are understanding that what is the file size limit, because we are talking about big data, and since we have to deal with the big data, these existing operating systems, they are already providing the file systems which can handle large amount of data. Then why do we need this Hadoop distributed file system? So the problem with the existing file system is that all the data, see, whatever data we store on one machine, that is not visible to the another machine, right? So although we have the large amount of storage, but it does not provide any kind of real-time parallel processing. We cannot do any kind of parallel processing. Because if we divide the data, even if we divide the data into files, let us say we have 5 machines, we break down the data into 5, like 1 terabyte data into 5 machines, and then Each machine is processing the data, but like machine one is not aware what is being done by the what data is being handled by the machine two, three, four. Similarly, so that means they are working like in the aliens. So working like working in the isolation. They are not aware about anything that what is being done by the another machine. So you can say these existing file systems, they are basically the local file systems. They have no idea what is available on the other nodes. So they can just have a local view of what is being done. So one machine, let us say I'm working on this my laptop or my computer. So this machine is aware about what is happening on this machine only. It is not aware about what is happening on the other machine. So this is the major drawback, that all these machines, they work in isolation, and they are not aware about anything. Even if we are able, we break down the large files into small files, and they can be processed parallelly. But all these files, you can say, they are being processed in isolation. So you can say if we have these five machines, they are working independent of each other, and the data is being processed. Now, when we talk about the distributed file system, basically it is a classical model, but distributed across the machines. So client should view the DFS as the same way the centralized file system. The distribution is hidden at the lower level. So you can say the DFS provides high throughput data access and the fault tolerance. So here we can say that the purpose of the distributed file system is to promote sharing of the dispersed files. That means whatever files are being dispersed, they can be shared among the various machines which are connected to each other through the network. Now, in the Hadoop file system, what is the benefit of HDFS, Hadoop Distributed File System? So, the complete task of breaking the files into the blocks, the small size data, and then allocating the task to all these machines. See at the top, see you can see the HDFS makes an abstract layer over the existing file system only. So you can say your HDFS is working on top of the traditional file systems only, but the HDFS takes care of all the things, and it can have a global view of everything that is happening on these machines. Now you can say there is one person, there is one automated system, there is a software which is sitting on top of all these machines, and that is called, we can say it is a master. So the master is taking care of all the things which are the all kind of storage and processing which is being done. So here you can say that when the input is received, so we have the HDFS, which breaks down the whole data. Let us say we have the one file which is being received, where we were discussing about that stock, finding out the maximum price of all the stocks. So let us say we have received the stock market data. Now this stock market data, that file has to be broken down into the multiple blocks. And now which block will be allocated to which particular machine for processing. So all this task is being done by the Hadoop distributed file system. So you can say it provides, basically HDFS provides an inexpensive and reliable storage for massive amounts of data. So it is optimized for relatively small number of large files. That means number of files, quantity of the files is less, but the size of the file is large. So you can say each file is likely to exceed the 100 MB multi-gigabyte files are very common when we are working with the HDFS. And it takes care of everything and maintains a complete structure and complete information about which particular block is stored at which particular location. And as we had discussed when we were discussing about the big data problem, so like if one block, like multiple blocks are being stored on the various machines, and each block is also replicated so that we can maintain the reliability of the system. So but the thing is, it is write once and read many type of system framework that is being provided. So we cannot modify the files once written. So if you want to make the changes, you will have to remove that particular file and again recreate it. So you can say there is no provision for the updation of that particular file. For updating the same files as we used to do, updating the table, just making a small change in the same table, that particular provision is not there in the HDFS. So it is basically, you can say this HDFS, it works on a master slave architecture. So in which have the one device that is, you can say, let us say we have 10 devices. We have studied about the master slave architecture where we have one server, we have all the other machines which are the slaves. So it is, everything is been directed and directed by the master node, that what task will be done by which particular slave. So same kind of architecture is being followed by the HDFS. That and here the master node is known as the name node, and the slave nodes, they are termed as the data nodes. Now, what is the size of the file, that size of the block in HDFS? In the previous version, the maximum size of the block that was supported by HDFS was 64 MB. Now, in the next version, you can say the latest version which we will be using, it breaks the file into small blocks of size 128 MB each. And here we have to understand that when, let us say, even if one record, the size of a file may be, if the which are being stored, you can say if the size of the file exceeds, say, the size of the block, so in that case, that half of the record will be stored in the another block, not in the same block. So we can say whatever is the size of the file, it is broken down into the blocks where each block is of size 128. So here, let us say if your file is of 1 GB, then can you tell me how many blocks will be created? Anybody? If you have the data file of 1 GB, how many blocks will be created? How many? 1 GB is equal to how many MBs? Simple
1020.
so just divide by 128.
88.
88.
Ma'am, 8.
So that is
8.
the equal. Yeah, that is equal to the number of blocks that will be created for that particular file. Okay. So if somebody asks you what is the number of blocks that will be created, you first have to ask what is the size of the block. Because in the older version, the size of the block was 64 MB, and in the latest version, the size of the file block is 128 MB. And then all these blocks are stored on the data node. And I told you, in order to accomplish the fault tolerance, that means if some fault occurs at the machine level, or you can say, well, if the machine fails, that means if the machine is failing, if a particular block is stored in that particular machine, let us say 3 blocks A, B, C were stored in that particular machine. So these 3 blocks will not be responding to the requirement client which are to be served. So in that case, what will happen? We cannot. So this is a HDFS is a fault tolerant system. So that's why what does it do? It maintains the replicas of these 3 ABC blocks onto the other machines. So if it fails, that means the other machine, the query will be fired to the another machine, and that machine will respond. Then we have the name node that keeps track of the blocks written on that particular node. Because see, if we have to, let us say it is our library system. In the library, we have large number of books, and all these books are being issued to all the students and the teachers. If the record is not maintained, if the record is not maintained, then how the people, the librarian will be serving the request of the users? If they maintain a record that this particular book is being issued to this particular person, so that it can be taken back on time. So here you can say only that particular part I wanted to give the example, that particular record is being maintained by the name node, right, which is the master node. So the name node maintains, or it keeps a record of all the blocks, which block is being stored on which particular data node. And even the task of, you can say, breaking down the file into the blocks is also being done by the name node. So here you can say this is the complete HDFS architecture. So what we have HDFS client. You can say some people who are demanding some data from the storage, right? So they are basically the clients. So what they will do, they will be requesting the name node. So we are not aware what is being done at the end. Let us say that Google is using the HDFS, and you can see Yahoo is using the HDFS. When you are writing a query on the Google or Yahoo search engine, maybe then in that case you can say we can say that you may be our HDFS client and you are making a query to HDFS, right? So there is some name node which is looking at the kind of data you are searching for. So basically name node maintains the metadata, right? So metadata is data about the data. So all the information that is required. So when the request is coming for processing some data, so in that case, it will first check on which particular node this particular, that means which particular data node the request for the data is coming for, let us say some X data. So X data is located on which particular data node. Then it will send a request to data node to process that particular data from its machine, and it will revert back to the HDFS client. Now, it maintains all the metadata like the name of the file, let us say the name of the file is X, which is divided into three blocks, block A, B, C, and next file is, let us say, M file, then M file is broken down into three blocks, 4, 5, 6, something like that. So here the name node stores, maintains all kind of information. Even the you can say the responsibility of maintaining the replicas, the balancing, and the heartbeats is everything is being done by the name node only. So for the fault tolerance, even the name node, it is also having a backup, that is, you can say it is a secondary name node which maintains the complete information about the namespace. Namespace is basically the complete structure of the files and directories where the data is being stored, and you all kind of relationships that will have file being stored, broken down into what, in how many number of blocks, and where these blocks are stored on which particular machine. So all the replica information that which particular, let us say, data node 1 stores block A, B, C, data node 2 stores block X, Y, Z. So where are their replicas? This information is also stored by the name node. So here you can say the data replica, we know it is required if the one data node containing data fails. In that case, the request has to be redirected to the other data node which is having the replica. And as soon as the machine restores, the other queries are being fired to that. And how does the name node knows that the data node is being active? This is through the heartbeat. So you can say the heartbeat is basically the mechanism through which the name node gets the information that a particular data node is active or not, whether it is working or not. So from there, it gets all the information, and accordingly, it keeps on sending the request to the respective data nodes, or keeps on redirecting the data nodes. So here you can say this through this example. Let us say we have two files. You find files variables, like it is foo.x. So it is divided into three blocks: 001, 002, 03. Similarly, we have another file that is var.txt. It is being divided into two blocks. Maybe just because you can say the size of the file was like that, that it is broken down into two blocks. So here you can say like foo.txt is 300 MB and var.txt is 200 MB. So assume HDFS is configured for 128 MB. So you can understand how many files which are required for that. So now the name node is storing only this information, that this particular file is being broken down into three blocks, and all these blocks, which block is being stored on which particular data node. And if you see the actual data, the nodes where the actual data is being stored. So the data is not being stored on the name node. The actual data is being stored on the data nodes only. And here you can see, if we here you can say if you see the rows and columns. So your block 001 is being stored on the first row, first column. Then for first column, last you can say third row, first column, and the third is 2 by 2. So here you can say the three copies of the block 001 are being created. Similarly, the three copies of block 003 are being created. So here you can understand the the replication factor is 3 over here. So if if you are searching for the data from the 001 block, and if node fails, so the request will be directed to some other node for fetching the data. And these block reports, they are periodically being sent to the node. And if there are, see, whatever changes are being made, whatever updations are being made, so everything is being you can say all this information is maintained by the name node only. So you can say the data nodes are only responsible for storage and processing of the data. So here you can see we have the centralized name node which maintains the metadata about the files, and then we have the many nodes, maybe thousands of nodes we have. This is because of these thousands of nodes that we are able to do the, you can say, process the large amount of data. We are able to handle the big data using the Hadoop. So it stores the actual data, files are divided into blocks, and each block is replicated n times. This n is by default is 3, and it can be changed by any of the users as per their requirements. So we have a file f, let us say its block size is 128, it is broken down into number of blocks. So the name node metadata, what does it have? So metadata, see, an important thing is the name node stores all such information into the memory. It doesn't store anything into the disk. If it store the all such information into the disk, then again the processing of data, the processing of the request of the user, that will get delayed. So therefore, all this information stored on which particular block, all this information is stored and maintained in the main memory. So there is no demand for paging of the metadata. Now, what kind of metadata it is? Like list of files, list of blocks for each files, then list of data nodes for each blocks, and file attributes like creation time, replication factor, all this information. And along with that, the transaction log is also maintained, the records, the files which have been created, the files which have been deleted. So all this information is being maintained by the name node. So which helps in requests from users in a better. So what is the system space? We have hierarchical file system with directories aside, so we can create and move, rename all those files. And this complete file system is made by the name node. So don't forget that the complete HDFS works top of the basic, the traditional file systems only. So any just talking about the data storage which is being done over there, and just automating the complete process of data storage as well as processing. For that particular task, we are using the HDFS. So at any meta information that changes to the file system, they are recorded by the name node. And application I have already told you that any applications you can specify the replication needs of your file as per your requirement. So the replication factor can be changed at any point of time. So the main properties, we say the main properties of the HDFS are they are large. In one instance may consist of thousands of server machines, and each storing part of the file system's data. Replication factor, see, everywhere we are talking about replication factor because it's very important. Each data block is replicated many times because it is because of the replication factor that your HDFS is fault tolerant, it is reliable. Then failure is the norm rather than exception. So there is, failures can't be avoided. The only thing is how to handle the failures. And this, you can say the HDFS provides a very beautiful mechanism in order to handle the failures and the quick way to recover from these failures. So the automatic recovery from them is a core architecture goal of the HDFS. And this name node, I told you, it is consistently checking the data nodes, and this checking is being done with the help of the heartbeats. Then we move on to the processing part. When we were discussing about the big data problem, we talked about the two components. One is the storage component, and another is the uh, your processing component. We have seen that using the HDFS, we are able to manage the storage. And now we have the distributed file, break down the large file to small files, and then we have a mechanism to manage complete or as the project. Then the next task of handling the big data, that is processing of the data. So component of Hadoop which helps the processing of the large data, that is called MapReduce. So MapReduce MapReduce consists of two functions basically. One is the map reduce. What does it do in the map? What does reduce function do? So Hadoop basically splits any job, any task. So it splits that particular job into individual tasks. So the number coded means part task you are in order to perform this particular task. There is task, and you can assign 5 people to that. Right? So this is how we break down the job into the number of tasks. We have each piece of the overall job into two process, to the parallel processing. Then mappers process in time. After that, what we have individuals who are broken down into small files, and then each file is being given to one person who will do this task, who will be processing it, right? Each taking one example in order to explain it in a better way. So the reduce function basically is one record at a time, and it will so basically we there are a complete job is being divided in one and that is two. Is being found or is to then final so that we talk about the election voting. So every after election, so for the okay. So, initially the was a traditional way of vote. Elections happen in each state. Elections happening. Single provinces, and the people vote over there in each province, in each of the districts, in cities. Every people are voting. So in the traditional system, all the votes boxes, ballot boxes, they used to be collected together and brought to the central point, and then they used to count. And it used to take many days in order to count the votes and then declare. But this is the traditional way of doing the task, the traditional approach. Now, what is the MapReduce approach? The MapReduce is the thing goes to the storage. That means the processing and the storage, they should be close to each other rather than far apart. So in order to solve this, so what do we do in the MapReduce approach? So rather than bringing the to the central office or the headquarters. Now, although you can say the vote, the ballot boxes, they are on particular booth only. Let us say if the let us say the smallest unit we have over here, state only. So for each state, let us say the people voted in the state, and now all the votes are being counted in that particular state only by the responsible persons. And after counting the vote, let us say we have parties who are participating in the elections. For the number of votes for each of the party are being counted, and that particular record is maintained, and then it is sent from each booth, or let us say each state to the central point. And then at the central point, what we have received. So you can say the amount of data that is being received from the booth A, B, C, D, E to the research center is very small. Let us say one lakh people voted in booth B. So from this count of 1 lakh people, so we have just counted the votes that party A got X, party A, B, C, D. Let us say we have 5 parties. So the party 1, 2, 3 have received X, Y, Z, P, Q, R amount of votes. So we have just 5 records from each of the booths. Let us say A, B, C, D, E. So to the total of, let us say we at the result center we have received 25 records. So from the 25 records, you can say the final results, calculation of the final results have become very fast as compared to bringing all the ballot boxes. Let us say if each one was having 1 lakh, so we bought all the 5 lakh ballots to the central point, and then there was the people at the central headquarters, they were counting. So it could take it would have it used to take more time as compared to the this MapReduce approach. So the booth-wise results are sent back to the result centers, and final result is declared easily and quickly using this way. So this is basically the MapReduce approach. So in the MapReduce anatomy, we say everything is in the form of key value pairs. The data of the complete data is in the form of key value pairs. So here you can say what is the key. If we see when we are storing the data and we want to process our data using the MapReduce model through the Hadoop, in that case we have to understand what is key and what is value. So here in this particular system, what we are looking for is we are looking for the number of votes received by the party X. So party 1, party 2, party 3, who have received the number of votes. So the names of the parties, let us say it is BJP, it is Congress, or it is BSP, whatever is the name of the party, it is basically a key, and the number of votes it has received, it is the value of that. So here it is managed like this. So from the MapReduce, we have received the key value system. So from the map, we are able to get the complete list of the keys and values, and these keys and values are being sent to the reducer function so that they can further aggregate in order to get the aggregate, in order to perform the aggregation of that particular data, so that we are able to get the final output. Just look at it. So here you see, this is the overall MapReduce word count process. So here you can say this is one example that is being performed using the MapReduce function. So let us say we have received this particular data of 3 records we have received. So all these records, you can say we have to put them into the key value pairs. So you can say in the first row, see whatever data is being received by the mappers, let us say all this first thing that we have to do is we have to split the data. So if we have to, let us say this is a sample file, so we may have multiple such kind of inputs which we have broken down into the broken down from the large file. So from this file, what we have done, so we have and each of these are the 3 records, and the mappers who receive the record, the persons who are receiving all this data. So what, let us, this is the name of this is the original file which has only 3 records, and these are first splitted, right? So in the real time, each record, you can say when we are performing the task of splitting the job into the task, we will not have a single record, we will have the multiple records, right? And now this record, this split input, right? So this becomes one unit, and this is being given to the mapper. So mapper is, you can say, a function which is responsible for processing this particular task or aggregating it into key value pairs. So here you can say DR1, BR1, River1. So here you can say this is corresponding to the example that, let us say, so dear, river, these are the names of the political parties, and these are the number of votes which are being received by all these 3 political parties. And after that, you can see that since the input was divided into, the main job was divided into 3 tasks. So we have corresponding to 3 tasks, we have 3 mapper functions. So these three mappers, so you have to remember that it will always, how many mappers are required in order to process the task. So it is always equal to the number of input splits that you have created. So from this mapping, what is being done, this the input that we have received. So this is a map function. So from here, the input is the task which is performed by the mapper. This is passed on to the reduce function. So the reduce function, so in between the mapper and the reducer function, there is a shuffling function which is responsible for, you can say, reducing the task of the reducer function. So here you can say what the reducer has basically done. It has reduced the task, the complete reshuffling is being done. We have identified that there are four parties or four individuals whose values are being there, and all these being, so here we are just finding the sum of these values. So we are not finding the max of this. So you can say beer, we had the two records for the beer. Beer comes at, let us say we are finding the frequency of the data. So the frequency, you can say this is a term frequency problem. So the term frequency, beer occurred twice, the car occurred three times, deer occurred twice, river occurred twice. So the shuffling, through the shuffling, we are able to aggregate this particular task. And then this particular task, which is in the form of key value pairs, this is being sent to the reducer, and what the reducer has received, beer 2, car 3, deer 2, and river 2, and then we are able to, the reducer gives the final result in, again in the form of key value pairs, that there are the frequency of beer, word beer is 2, car 3, deer 2, and river 2. So this is how the complete MapReduce framework works for a particular application. So here it was performing the task of basically the counting, the you can say finding the frequency of the terms. Similarly, we can find out the voting count, the total. So once we have the all the counts from all this, once the mappers have done their task, so through the shuffling we will be able to find out the various values of the various parties, and we can find out the sum. Similarly, if we can also find out the same process can be used to find out the maximum value of a stock price. So this is how your MapReduce function works. So we'll take another example in the next class tomorrow. And for getting into the further details for processing of large files, and how many mappers can be there, how many reducers can be there, how the combiner functions work. So all this task we will be doing tomorrow. And for getting into the further details for processing of large files, and how many mappers can be there, how many reducers can be there, how the combiner functions work. So all this task we will be doing tomorrow.